guys, hello everyone, this is Saurav here and welcome to today's session on the Vedantu VOS channel. This is in continuation of whatever we were discussing the last week. And last week हम आपको याद होगा तो हमने कवर किया था migrations to electron deficient oxygen. आज हम कवर करेंगे migrations to electron deficient nitrogen और इसको हम दो पार्ट में करेंगे. Please remember that migration to electron deficient oxygen, migration to electron deficient nitrogen और बाद में हम करेंगे माइग्रेशन टू इलेक्ट्रॉन डेफिशिएंट कार्बन. ये सारे माइग्रेशंस किसी न किसी फॉर्म में इन द जेई एग्जामिनेशन और नीट और इन द INCHO दे गेट आस्क्ड, सो इट इज इंपेरेटिव टू नो देम वेरी वेरी प्रॉपरली. हमने एक चीज और देखा था कि जब भी किसी इलेक्ट्रॉन डेफिशिएंट चीज पे माइग्रेशन होता है देन माइग्रेट करने वाला ग्रुप हमेशा न्यूक्लियोफिलिक होता है. ओके, migrating group is always nucleophilic. ठीक है, क्योंकि इलेक्ट्रॉन डिफिशिएंट चीजों पे अगर माइग्रेट कोई अगर ग्रुप कर रहा है तो ओनली दैट ग्रुप कैन माइग्रेट टू एन इलेक्ट्रॉन डिफिशिएंट स्पीशीज व्हिच इज इलेक्ट्रॉन रिच. Electron rich species are nucleophilic and therefore migration to electron deficient species, whether it is nitrogen, oxygen, carbon, will always happen through a nucleophilic entity. So in today's session, the first reaction of this type will be Bakeman's rearrangement. Bakeman rearrangement is very very important from the IIT JEE point of view. And Bakeman rearrangement होता क्या है? Bakeman rearrangement में हम करते क्या है कि we take an oxime. ये आप जो देख रहे हो इसको हम बोलते हैं oxime. Oxime is made to react with an acidic compound, either H plus or PCl5 or PPA, BH, SO2Cl, SOCl2, P2O5, BF3, Al2O3. कोई भी सब्सटेंस अगर एसिड की तरह बिहेव कर रहा है, अगर ल्यूइस एसिड भी है तो उसके साथ एक ऑक्सीम रिएक्ट करके इट विल टर्न इट इनटू एन एमाइड. चलो देखते हैं इसका मैकेनिज्म कैसा होता है. मैकेनिज्म गोज लाइक दिस. सो पहले आपको यह समझ लेना होगा कि ये ऑक्सीन बनता कैसे है. तो मैं यहां पे लिख देता हूं कि ऑक्सीन बनाने के लिए ना आपको एक कार्बोनिल कंपाउंड लेना होगा, एक एल्डिहाइड या कीटोन, जैसे कि यहाँ पे PHC डबल बॉन्ड Me का बनाया गया है ऑक्सीन. सो यू विल टेक दिस कीटोन एंड यू विल रिएक्ट इट विद NH2OH और इसकी रिएक्शन एक एसिड के प्रेजेंस में अगर की गई तो we will get PHC double bond NOHMe. याद रखो कि ये हमेशा ज्योमेट्रिकल आइसोमेरिज्म शो करने की कैपेबिलिटी रख सकता है. ज्योमेट्रिकल आइसोमेरिज्म will be formed or not will depend on these two groups. Okay, अगर both of them are phenyl, then geometrical isomerism will not exist. If one is phenyl, one is, so both of them have to be different for this oxime to show geometrical isomerism. So what is the mechanism like? What we do is we start with PHC double bond O double bond NOHMe. This reacts with H plus. जब H plus से रिएक्ट करता है तो H plus goes and attaches itself to OH. Okay. Now, the important point about Bakeman's rearrangement is that when the moment oxygen gets a positive charge, this OH2 will leave. ये बाहर निकलेगा. And what will migrate to nitrogen is a group which is trans with respect to OH2. So the group trans with respect to OH2 will migrate to nitrogen. Okay, तो ये जो ग्रुप है ये यहां माइग्रेट करेगा एंड वी विल बी गेटिंग PHN double bond C with a positive charge and Me. Now this will react with H2O, PH, N double bond C, and it will become OH, and this will undergo tautomerism. It will become PHNH C double bond O M E. Okay, देखो exactly यही बन गया. The reason is this OH and this pH are trans with respect to each other, या फिर आप बोल सकते हो they are anti with respect to each other. So if the group which migrates is always the one which is trans with respect to the OH group. अगर मैंने ये कंपाउंड लिया होता, had I taken this PH C double bond N OH Me, and it would had reacted with H plus, तब क्या होता? Then Me would had migrated to N, and we would have gotten this compound eventually. So product बनाना काफी easy है. The group which migrates is attached to nitrogen और carbon को double bond होगा. ठीक है? So let's look at some more features of Bakeman's rearrangement. The first important feature is group trans with respect to OH migrates. Next, if two different oximes are taken together, तब क्या होगा? मान लेते हैं कि आपने ये ले लिया है PHC double bond, PHC double bond N OH Me, and you have taken ET C double bond N OH, and यहाँ पे आप ले लो isopropyl group. Okay, if you react both of them together in presence of H plus, what will be the product obtained? What we have observed is that we will be getting this as the product. We will be getting this as the product. But we do not get anything like this. ET NH C double bond O Me PH NH C double bond O IPR. ये जो प्रोडक्ट्स हैं ये मुझे नहीं मिलते हैं. They are not obtained. इसका मतलब ये है कि this migrates over here, this migrates over here, intermolecular migration does not occur. So reaction is intramolecular and no crossover products are found. Okay, no crossover products are found. So this is something that you have to remember. क्रॉसओवर प्रोडक्ट्स फॉर्म करने के लिए इंटरमॉलिक्यूलर रिएक्शन होना चाहिए. क्रॉसओवर प्रोडक्ट्स का मतलब कि अगर इंटरमॉलिक्यूलर रिएक्शन हो रहा है देन वी विल हैव क्रॉसओवर प्रोडक्ट्स. थर्ड, मान लेते हैं कि एक कार्बन के साथ 3 एल्काइल ग्रुप लगे हुए हैं, R, R1, R2, and It is like this. Okay. Let's say the absolute configuration of this carbon atom is S. This is the absolute configuration. Okay. When you perform a reaction with H plus, you will get an amide, and amide कुछ इस तरह का बनेगा. R, R1, R2, NH, C double bond O, Me. If you are being asked that what is the absolute configuration of carbon over here, please remember कि absolute configuration is still S रहता है. So the absolute configuration at the migrating carbon doesn't change. Remember, it doesn't change. Okay? So, three important points. Group, which is trans with respect to OH, migrates to nitrogen atom. Second, no crossover products are formed. Third, if there is a chiral center attached to a carbon and that is one which is migrating, the chirality of that center is preserved. The configuration does not change. Okay. Let's look at some examples. So, अगर इसका दिया गया है and I have been given PCl5, I have to write the final outcome. So, OH के trans कौन सा है? ये वाला group, and therefore that will migrate. So, how do I write product? So, I'll write ET, C double bond O, NH, and I'll just attach this group. In this case, OH will move out and methyl will migrate over here. So our product will be ET, C double bond O, NH, Me. This goes out, phenyl will migrate, product will be Me, C double bond O, NH, EH. Okay? This is how the reaction will take place. I hope there is no query in this. So let's move on to the next reaction, which is known as the neighbor rearrangement. Neighbor rearrangement is a very interesting mechanism, very interesting case. Usually neighbor rearrangement को InChO के लिए पढ़ाया जाता है. It is not taught for the level of JEE, but एक छोटा सा आइडिया आपको मिल सकता है कैसे. आप एक चीज समझने की कोशिश करो कि जब भी हम कोई ग्रुप को माइग्रेट कराते हैं, then that group has to migrate with certain pre-decided conditions. जैसे कि इसमें हमने फिनाइल को माइग्रेट कराया था पिछले वाले रिएक्शन में. So phenyl was being migrated. So phenyl is migrated because of the reason that the rule set is that a group which is trans with has to migrate. Orbital overlaps are actually the important reason. The bonding MO overlaps with the anti-bonding MO over here, and therefore that is the important reason. The group which leaves, उसको हटाने के लिए, if it is not a good leaving group, then we use H plus or we use TSCl. So in this case, we have used a ketoxine tosylate, and ketoxine tosylate is being converted into an alpha amino ketone. इसमें OH नहीं है लेकिन OTS है. तो इसका रिएक्शन होता कैसा है? इसका मैकेनिज्म जानना ही इंपॉर्टेंट है क्योंकि this is not a very common reaction. So this goes like, so this is OTS, pH. अब होता क्या है कि सबसे पहले ना ये NaOET रिएक्ट करेगा. NaOET is a base. ETO minus will react and I will be getting pH first and foremost. It will remove the most acidic proton from here. So it will remove the most acidic proton which is compound present. Now this N minus will attack over here and this will go out. Perfect. And we end up getting something like this. एक 3-membered ring बनता है with pH over here, with pH over here. Clear? So once this is created, आपको ये समझना होगा कि this entity is not quite stable क्योंकि ये 3-membered ring है. So not very stable because 3-membered plus heterocyclic plus C double bond N. So it is highly strained a ring. Okay, काफी strain है इसमें. So what will happen is that it will go like this. pH it will react with H2O and OH will attach itself over here and nitrogen gain a hydrogen. So pH okay. In the next step, your ETO minus now removes a proton from the OH group. It takes this proton, this comes over here and this opens. 1, 2, 3. 3 step में ये हो जाए. मतलब it's a concerted mechanism. ETO minus first abstracts a proton. The electron moves between oxygen and carbon and the bond between carbon and nitrogen break. And therefore we end up getting something like this. pH NH2 double bond O pH. Okay. So this has to be pH, cannot be Me. That is misprint. So this is how the reaction takes place. Please remember that again it is a migration to an electron deficient nitrogen because ये OTS अगर यहाँ से निकल गया तो nitrogen will have a positive charge and that will create a electron deficient nitrogen. Okay. So never rearrangement is just for knowledge enhancement. इसके ऊपर questions कभी आ गए तो ठीक है, नहीं आया तो बस ये आपके बुक्स में जाएगा. Okay. The next one, and it is very important from the JEE point of view as well as from INCHO point of view, that is Hoffman rearrangement. Hoffman rearrangement is an absolute favorite for JEE Advanced people who make these papers because इसके ऊपर कितनी बार क्वेश्चन आ चुका है. Hoffman rearrangement में होता क्या है कि we convert a primary amide to a primary amine and this is actually a very good method of preparing primary amine. Primary amines की preparation का एक ये method हो जाता है. इसमें करते क्या है कि we react an amide with bromine in presence of NaOH or sodium hypobromite NaOBr, and a reaction takes place in which an isocyanate is formed. चलो देखते हैं कि ये मैकेनिज्म होता कैसे है. सो इस रिएक्शन को हम दो पार्ट में पढ़ते हैं. This mechanism for this reaction is studied in two parts. Part 1 of the mechanism is conversion of amide to isocyanate. Part 2 is conversion of isocyanate to amine. Okay. So remember, the Hoffman rearrangements mechanism takes place in two parts. Let's study each of them. So part 1 कैसा दिखता है? Part 1 करते क्या है कि let's say you have pH, C double bond O, NH2. RNH2 की जगह मैंने AR, यहाँ पे आप AR भी लिख सकते हो, यहाँ पे आप हाइड्रोजन भी लिख सकते हो, कुछ भी आप लिखो. ये R, AR या फिर हाइड्रोजन नाइट्रोजन के साथ अटैच हो जाए. तो मैंने PHCONH2 ले लिया, and I have first and foremost I will react this with OH minus. This will create PHC double bond O, NH minus, and this NH minus will function as a nucleophile and will react with bromine. Will create PH C double bond O, N H Br. This PH C double bond O, N H Br further reacts with OH minus. यहाँ पे जो ये स्टेप होता है ना, this is the rate determining step of the reaction. और ये इसमें एरोज को आपको ऑब्जर्व करना होगा. देखो कैसे होता है. OH minus is taken, OH minus takes up this H plus. ये इलेक्ट्रॉन यहां आते हैं. This PH moves to nitrogen and this Br goes out. That means 1, 2, 3, 4, and we get PH N double bond C double bond O. Okay, you get an isocyanate. You get an isocyanate. This is a concerted mechanism. हम क्यों बोलते हैं कि this is an migration to an electron deficient nitrogen? इस नाइट्रोजन को अगर आपने इस हाइड्रोजन को अगर आपने हटा लिया, उसके बाद ये अगर Br निकल जाता है, देन हमें एक नाइट्रीन जैसा इंटरमीडिएट मिलता. However, नाइट्रीन was not obtained, but hypothetically एक नाइट्रीन जैसा इंटरमीडिएट मिलता. And therefore, we say that the migration to nitrogen is taking place because nitrogen becomes electron deficient. Okay, this is part 1 of the mechanism. What does the part 2 of the mechanism look like? So the part 2 of the mechanism looks like this. So you have PH N double bond C double bond O. It reacts with OH minus, attacks on carbon. We get PH N minus C OH. Okay. An intramolecular proton transfer has taken place. Perfect. ये यहाँ पे आता है, ये इधर चला गया, and you get pH NH minus plus CO2. वाटर में क्या होगा कि ये फिर से pH NH2 बन जाएगा, और ये जो CO2 है ये तो एक एसिड होता है, एसिड के जब एसिडिक ऑक्साइड है तो ये OH माइनस आयन के साथ रिएक्शन करके एक HCO3 माइनस आयन बना देता है. ओके, इफ यू काउंट द टोटल नंबर ऑफ OH माइनस आयन्स यूज्ड, तो आपको यहां पे एक OH माइनस आयन दिखेगा, यहां पे आपको एक दिखेगा. Similarly, you will see a OH minus ion over here, and then you will see a OH minus ion over here. So total मिला के we have a 4 OH minus ions. Okay, in total we have 4 OH minus ions which are participating in the reaction. And how many Br2 molecules are involved? Br2 is involved over here. So 4 OH minus is to 1 Br2. 2017 or 16 JEE mains asked a question that in Hofmann bromide reaction, what is the ratio of the number of moles of OH minus is to the number of moles of halogen which is employed? So it is 4:1. Okay, this creates a primary amine. Now, इसमें कुछ important points हैं that are, what are the features? First, reaction is intramolecular. Which means no crossover products. By intramolecular, I mean that a step in which the amide converts to isocyanate. So if you are taking, if you are taking Me C double bond O NH2 and Et C double bond O NH2, this nitrogen is N15, and you are performing Hofmann bromide reaction on both of them, on the mixture, then what you will be getting is MENH215 plus ETNH2. Only this is obtained. You would not get ETN15H2 or MENH2. Okay? There is no crossover product. Okay? The next feature is, if this carbon is chiral, and let's say its configuration is R. Okay, configuration is R. This is R dash a group. If I perform Hofmann bromide rearrangement, then the product form will be pH C R dash H NH2, and the absolute configuration over there will continue to be R. इसका मतलब during migration the Okay. During migration, the stereochemistry of the migrating group does not change. This is very, very important. बहुत समय mistake हो जाता है लोगों से, and you would never know that when would a mistake come up. So please do remember these two very important points about Hofmann bromide reaction or Hofmann rearrangement. Hofmann bromide reaction or Hofmann rearrangement both are alike. Okay. And the third point is, जो आपके पास ये isocyanate बना है ना, R N double bond C double bond O, this isocyanate when reacts with H2O OH minus forms amine. This amine will always have the alkyl group amide. Okay, इसमें never 2-degree amine is formed. Okay, this is like a given. जो एल्काइल ग्रुप में जो आर ग्रुप है कार्बन के साथ अटैच्ड, वही नाइट्रोजन के साथ अटैच रहेगा, उसी के कारण आपके पास एक अमीन बन के आएगा और 1 डिग्री अमीन बनेगा, तभी भी आपके पास 2 डिग्री अमीन नहीं बनेगा. ओके, सो दैट्स ऑल फॉर टुडे गाइस. आई होप यू एंजॉयड दीज 3 रिएक्शंस. इन तीनों रिएक्शन को प्रैक्टिस कीजिए, क्योंकि जो नेक्स्ट हम इस टॉपिक पे पढ़ेंगे, माइग्रेशन टू इलेक्ट्रॉन डेफिशिएंट नाइट्रोजन पार्ट 2 will depend on Hofmann bromide rearrangement. और उस दिन हम जो पढ़ेंगे वो we will be studying Curtius, Lawson, Schmidt rearrangements. Okay, so that's all for today guys. Thank you and have a lovely time.